Hi, and welcome to this first video on curve sketching. You spent a lot of time looking at quadratics. You should be familiar with quadratic curves. So what we're going to do in this video is look at extending all that knowledge to cubics, power 3s, quartics, power 4s. Okay. In this series we're going to be looking, as I said, at cubics, quartics, and then in the next video we will have a look at the reciprocal curves, look at positive curves, negative curves, and looking at where the curves intersect. I'm just trying to bring all your knowledge on polynomials and quadratics, roots, intercepts, and all that kind of stuff all together in a sketch. So, as I said, we're going to be having a look at curves up to and including quartics, that's power 4s, and then make sure we understand the difference between the positive versions of those and the negatives. So, here we go. Quadratic, I'm going to rattle through this one fairly quickly because you should be fairly familiar with it. There's our U-shaped curve for positive quadratic. There's the N-shaped negative quadratic. And as soon as you start adding in extra coefficients, all that happens essentially is the curve just kind of moves across and up and down a little bit. So you should be familiar with those. Now let's have a look at what happens with a cubic. A cubic, you get this kind of S-shaped curve, and particularly want to focus on the negative values of x. So that's these ones down here. Think about what happens when you cube a negative number. Well, minus times a minus makes a plus. Times by a minus again, we're back into the minuses, which is why this curve is negative when x is negative, down here. The negative version of that flips all that around. So if you consider what's going on up here, for negative values of x cubed is negative, and then we want minus x cubed, we want minus that, so you're adding another minus into it, which turns it back into a positive. So the curve just effectively flips around. And what happens when you put in extra coefficients is what you get, what I like to call the bumps and the humps. So it essentially just kind of adds extra curves into the middle section of the curve, and you end up with essentially still that S shape, but let's say with extra bumps and humps going on. And we will have a look at kind of what's going on with how we find out where these points of intersections are. So we've got one there, and let's go one there, one there. We'll also be looking at where it intersects the y-axis down here as well. Quartics. Now, a quartic curve is essentially basically the same shape as a quadratic. The reason being, if you think about what's happening with the power 4 with the negatives, minus times a minus makes a plus, times by a minus takes it back to a negative again, and then finally times by another minus brings it back to a positive. So again, any time you do anything to the power 4, if it's positive or negative, you're going to get positive values. So essentially, it's exactly the same U shape as a quadratic, but just the values increase a whole lot quicker, so it looks a lot narrower. Same principle for the negative one. Again, it's that upside down N shape, same as a quadratic. And that one there is a negative power 4 equation because it's upside down, it's an N shape. And again, you can see it's got the bumps and the humps in it. And those appear, let's say, as you add in extra values of A, B, C, D. And it just makes the curve a little bit more complex. So, 3 for us to have a go at in terms of sketching. And we'll go through a kind of a procedure just to make sure you're thinking very carefully about all the things that need to be thought about. So let's just start off with this first one. What I'm going to do to begin with is think, okay, what kind of type of curve is that? And clearly straight away we can see that one is a positive cubic. In this case, that is blatantly obvious because you can see it's standing out there, the bit that's circled, but it's not always quite as straightforward as that, so that's why I'm just emphasizing that point now. Next thing I want to think about are the intercepts, in this case the y-intercept, which occurs when the x-coordinate is 0. And if you look at that equation, when x is 0, you've got 0 cubed minus 5 lots of 0 squared minus 6 lots of 0. The whole thing is just 0. So this particular curve is going to go through the origin. For the x-intercepts, that's happening when y equals 0. So what we're going to do is stick y equals 0 into our equation. So we're going to replace the y there with a 0. And now we've got an equation to solve. What can we do with that? Well, we can factorize it, take out a value of x. So we've now got a quadratic inside the bracket there. Factorize that quadratic. There we go, x plus 1, x minus 6. And so that gives us 3 solutions, 0, minus 1, and positive 6. Right, we've now done all the thinking we need to do. We've got all the information we need. So let's whack that onto a sketch. And again, a sketch that you'll notice straight away there's no numbers on the axes. I'm not drawing this to scale. I'm not carefully measuring things out. I've just drawn a set of axes. And now all I'm going to do is put the information from the left-hand side of my screen onto the graph. So there, minus 1, 0, 6. And we know it's going to go through 0, 0 as well. I know it's a positive cubic, so it's going to start at the bottom down here, going to go up, bumps and humps, and finish off at the top here. And the only way that's going to happen is if it goes up through -1, down through 0, and then back up through 6 again. So there it is. There's my sketch. Sorted. Right, on to the next one. Now, for part A, it was clear we said, okay, it's a cubic. We knew that because coming from here you can see it. But what's going on with this one? What kind of curve is this? Well, what we've got here is we're going to get an x squared coming from the first bracket. And we've also got a minus x coming from the second bracket. And so the cubic term is going to come from doing the x squared from here times by the minus x. So that's going to make it a negative cubic curve. So that's what I was saying about it not always being 100% obvious. You do need to do a little bit of thinking. So we know it's a negative cubic. Let's go through the same procedure again. Y-intercepts. That's going to happen when x equals 0. And what's going to happen to these brackets when x equals 0? Well, we're going to get y equals 4 squared and 3 minus 0 is 3. Tighten it up, that's going to be 48. So we know it's going to go through the point 0.48. And the x-intercept again when y equals 0. Put 0 in. Now the factorising has already been done for us. Now, notice this one, we've got, essentially that is x plus 4, so that tells us we've got a repeated root, i.e. 2 roots, but both occurring in the same place. So it's occurring at x is -4. So what that means is the curve is just going to touch the axis at -4 and then go away from it again. So we'll have to think about that when we do our sketch. And coming from the other bracket, we've got a root at x equals 3. So again, we've got all the information we need. Here comes our sketch. There's the -4. 48 and 3, and now we've got to make sure we've got that repeated root at -4, so the curve is going to just touch that and go away. We know it's a negative, so it's going to start at the top here, finish down the bottom there, and there it is. One thing I would mention with this one is just be a bit careful when you're sketching. We don't know that this point here is actually at -48, that's why I've made sure I've extended it beyond the 48. So the kind of the maximum point here is not actually on the axis because we don't know that the maximum point would be on the axis. So I've just put that going up through 48 and up a little bit further just to make that clear. Cool. And then the final one. Okay, we've got two quadratic brackets being multiplied together here. So 2x squared times x squared, that's going to give me power 4. They're both positive, so we've got a positive quartic, positive power 4 curve. Same deal again, y-intercept when x is 0, that's going to be coming from, let's say if we have a look at this bracket here, those are 0, so we're left with -3 times by 9, so that's going to be -27. When x is 0, sorry, what am I saying, when y is 0, we've got that to solve. Okay, coming from that bracket there, bit of factorising, from that bracket, a bit more factorising, and again, look, we've got a repeated root, so we're going to have to think carefully about that one. So we've got our roots at -1/2, 3, and our repeated root at -3. There's my axes, and again it's a positive quartic, so again I'm thinking, okay, I've got to start up here, it's going to come down, it's going to bumble about a bit, and then disappear back at the top. And I know I've got a repeated root at -3. So thinking about all of that, there we go, there's my curve.